Hello everyone, we are the Group 1. My name is Precious D. Villanueva, the leader and the technician of the group.
My name is Rafael Adrian Villachica, and my role to our group is mathematician.
My name is Tracy V.A. Capalla, the researchers of the group.
I'm Francine Alia Bismar, the researcher of the group.
My name is Alexandra Paula B. Magbanwa. The role is the researcher of the group.
Me and my team are going to present real-life situations and discuss solutions that make use of functions. Our presentation has two major parts. The first part is the plastic waste pollution, and the second part is the fast spreading of the COVID-19. These two major parts are also divided into three parts. The first one is the introduction, which is about how these two situations affect not just in general, but specifically in our businesses, transactions, and education. This part will be presented or introduced by our researchers, Ms. Francine Bismar and Mr. Siegfried Kapaya. Second part is the mathematical explanation that could help us solve these two real-life problems. This will be presented by our mathematician Mr. Rafael Lachica. And third is about the implementation, strategies, and tactics to solve these problems, and that will be given by Ms. Alexandra Paula Magbanwa. So let's now begin with the plastic waste pollution to be presented by Ms. Francine Bismar.
The synthetic plastic was first produced for almost 100 years ago, which marks the beginning of the global plastics industry. However, there was a realization that on the 1950s, there was a rapid growth of the global plastic production. On the year 2015, it increased nearly to 381 million tons of plastics. This massive amount of plastics is not just numbers, but it affects the life and specifically us. 99% of plastics cause climate change. 91% plastics are not recycled. Marine animals are under threat. Over 1 million seabirds die every year. Ultimately affecting us, we are eating plastic. 1/4 of fish have plastic. 83% of tap water samples contain plastic. Each year, 400 million tons of plastic is produced, and 40% of that is single-use plastic. We will only use once before it is banned. Example of single-use plastic are carrier bags and bottles. More than 8 million tons of plastic enter the world's ocean each year, and most of that escapes from land.
Thank you, Ms. Francine Bismar. Now let's listen to Mr. Rafael Lachica's explanation in mathematical concept about the problems in plastic waste pollution.
The mathematical explanation for plastic waste pollution. In finding the total number of new cases, we will use the formula f of x equals a times 1 plus x equals 3, where x is the annual increasing rate of plastic usage after 3 years, a is the number of plastic used annually in tons, and f of x is for the total number of plastic used after 3 years using the increasing rate. Example, if in 1950 we have 2 million plastic tons and in 1953 we have 3 million plastic tons, our A is 2 million and our f of x is 3 million. By using the formula f of x equals a times 1 plus x equals 3, our x is equal to 14.5%, and that is the annual increasing rate of plastic usage after 3 years. Now, if we have 5% annual increasing rate, using the f of x equals a times 1 plus x equals 3, our f of x will be 2,315,250 plastic tons after 3 years. This is lesser than 3 million, which is good. In this graph, you will see that the higher the increasing rate of plastic usage, the higher of plastic will be produced or used. So it is good to do recycling, proper waste disposal, or even implementing zero waste projects to have a lesser plastic to produce or use.
Thank you, Mr. Rafael. Now we have seen and understood the mathematical explanation about the problems in plastic waste pollution. Let's now listen to Ms. Alexandra Magbanwa's presentation about the implementation, strategies, and tactics on how we can solve the problem.
We are living on a 4 billion years old Earth. Humanity existed in only 1% of the 4 billion years timeline, but we made a huge change in our world. This is because of our habit to live and survive, to take care of Mother Earth. It has to be from ourselves, specifically in our daily activities, such as proper waste disposal and management, by applying the reduce, reuse, and recycle. Change habits into avoiding the usage of plastic, like single-use products and disposable. Public places must implement zero-waste projects, such as zero-waste groceries or refills shop. These strategies or implementation can help reduce the rate of plastic usage and help prevent pollution.
Yes, thank you, Miss Alexandra. Now let's proceed to the second major part or topic, which is about the fast spreading of the COVID-19, to be presented by Mr. Siegfried Kapaya.
The fast spreading of COVID-19. COVID-19 is not only a global pandemic or health crisis, it has also severely affected the global economy and financial markets. There is a widespread agreement among economists that it will have severe negative impacts on the global economy. Some businesses have encountered bankruptcy and education system changes that made our students, teachers, and schools getting even more behind in a changing world. Social distancing protocols have been made so far around the world, but due to the effect people rushes to have money to survive and this pandemic, such as frontliners, government offices, factories, and markets, this virus has given a total of 33 million cases with 22 million recoveries and almost 1 million deaths worldwide.
Thank you, Mr. Siegfried. This problem really made a big change in our world today. Now let's listen to Mr. Rafaela Chica's mathematical explanation about how fast COVID-19 spread.
The mathematical explanation regarding the fast spreading of COVID-19. In finding the total number of new cases, we will use the formula f of x equals a times 1 plus rx, where a is the number of population carrying the virus, r for the infection rate, x is for the number of days, and f of x is the total of the new cases. First, we need to get the infection rate by using the formula r equals b over a, where a is the number of population carrying the virus and b is the number of cases that is added by the next day. So, from our example, we have 3,028 cases in August 9, 2020, and in August 10, there are 6,735 total cases. The difference is 3,707. These are the cases added after 1 day. Then, we need to get the infection rate. We will use the formula R equals B over A, the number of cases that is added by the next day, which is 3,707, divide it by the number of population carrying the virus in August 9, 2020, which is 3,028. So, the infection rate is 122.424%.
Thank you, Mr. Rafael, for the explanation. Now, if we change the infection rate into 50%, like following the social distancing protocols and other government advices by using the formula f of x is equal to a quantity 1 plus r closed quantity to the power of x, we are going to change our infection rate to 50% and making it into 0.5 in decimal, and our x is 3 since we are basing on 3 days for this situation. And now we're going to solve for it. 3028 times 1.5 to the power of 3 or cube, which is equivalent to 10,219.5. But since we are talking about population here, it will become 10,220. So in 3 days, there will be a 10,220 cases in a 50% infection rate. By this graph, we can see that in the left side, there is a 122.424% infection rate, which is higher than on the right side, which is 50%. The higher the infection rate, the more cases there will be. So now let's call again Miss Alexandra Magbanwa to present or introduce us the conclusion or solution to solve this kind of problem of us to lessen the infection rate of the spreading of COVID-19.
COVID-19 made the world to change even faster. This is also making most of human activities in failure. But despite that, we humans are very creative and innovative. The practices we know are doing the social distancing and staying at home that can basically help reduce or lessen the rate of infections. To really solve the problem, business and other companies have been using online to still connect despite the new normal, such as online concerts, online classes, delivery services, the use of digital wallets, and anything that can help in this pandemic. Using online is the new normal way people deliver and continue their transactions to avoid the rapid growth or spread of virus. We must avoid face-to-face interactions to ensure and keep ourselves healthy because health is wealth.
Thank you, Miss Alexandra. Health really is wealth. At any time, we can encounter different kinds of problems, but rather than blaming, we should keep moving forward and always remember that the stars shine the brightest when the night is darkest. We are the Group 1. Thank you for listening. Hope that you gain knowledge and God bless.